Hello and good afternoon. Thanks everyone for being here this afternoon. It's a pleasure to bring to you this very important talk and session today. Welcome to ASU Health Grand Rounds. For those that are here in person, we have a great group today, and those that are online, welcome and thank you for being here as well. I'm Dr. Kristen Will, Associate Dean for Interprofessional Education and Community Engagement for the John Schufeld School of Medicine and Medical Engineering, and also an Executive Director at ASU Health and a clinical professor at ASU. So it's nice to be with you all. We have a great session today on immersion technology, artificial intelligence, and biosensing converging to transform healthcare. Before I introduce our speaker today, Dr. Walter Greenleaf, I'd just like to go through a couple housekeeping pieces with everyone. And click on that. We do offer continuing education for the health professions across the health professions. Our speaker today does not have any disclosures. And these are our accrediting bodies and the associations that we represent. For those of you that are interested in obtaining continuing education credit for this session, there will be an opportunity to complete an evaluation form at the end of the session. We'll also follow up and send that online if you miss it. We will have a Q&A throughout the session. If you have questions, those that are online, you can put them in the Q&A. I will be moderating the Q&A, and then there will be time at the end for question and answers. Those that are in the audience, remember your questions, and we'll take those in real time here. We do have restrooms right outside the door, and for those that RSVP'd, we have lunch refreshments for everyone as well. I'd like to say a special thank you to all the students who came during finals week. That shows a lot of dedication and perseverance, and we wish you all very much good luck. So without further ado, I'd like to introduce Dr. Walter Greenleaf. Dr. Greenleaf is a neuroscientist and medical technology developer at Stanford University. With over 35 years of experience in medical research and product development, he is a leading authority in digital medicine and the clinical applications of virtual reality technology. Dr. Greenleaf has developed systems that address a wide range of conditions, including post-traumatic stress disorder, anxiety disorders, stroke, addictions, autism spectrum disorder, depression, neurodegenerative diseases, traumatic brain injury, neurorehabilitation, and other complex challenges in healthcare. Dr. Greenleaf is the Research Innovations Director for the Stanford Medical Mixed Reality Center. He also serves as an advisor to the Stanford Virtual Human Interaction Lab and the Stanford Wearable Electronics Program. He has many other advising roles at other both international and national technology for health integration. And so without further ado, I'd like to turn it over to Dr. Greenleaf and thank him so much for being here. Thank you.
Well, thank you, Kristen. It's my honor to be here. As you can tell from the topic, it's a very broad area. Any one of those particular areas and their impact on healthcare could be a multi-hour discussion. So I asked Kristen, what should I do with such a broad topic? She said, well, skip every third word. It's a smart line. And so you'll do the predictive modeling and fill in the gaps. So I hope we can foster discussions. So there's some time towards the end. And I should say at the very beginning, I'm so impressed by what I've learned is happening here. This is a real center of excellence, moving healthcare, education, and technology forward. And I'm pleased to be learning more about the action that's going on here. So jumping right in.
So it kind of goes to sleep a little bit. Let's see here. And then now try it.
There we go.
Try it and see if it goes forward.
It's going forward now.
Great.
So briefly, what we'll try and do is give an overall context of what's going on in digital health and new technologies briefly. I'm going to give some examples of the spectrum of applications that are leveraging new technologies such as immersive technology, AI, and biosensing. Talk a little bit about the research foundation validating these approaches. Give some specific examples that I think are pretty cool. And then, because I'm a neuroscientist by training background, I'll emphasize what is the mechanism of action, what is the mechanism of adherence for these new technologies, why do they work and why should we care? And then I'll talk about some of the concerns and challenges. And if there's time towards the end, I'll give my overall thoughts. And I'm overly optimistic, so I hope you'll bring me down to earth a bit on some of that optimism. Let's go to sleep.
You focus.
I'll just stand at the podium and do it this way. Okay, so what I'm particularly excited about is the convergence of some real breakthrough technologies. We're finally getting to the point with some smart glasses technology and other ways of providing more robust immersive experiences empowered by generative AI and in other systems that using AR clinically, AR, VR, XR, we're still working on the nomenclature, is going to make a big difference in terms of being able to use a simulated environment to evoke a cognitive state, measure emotional and cognitive states, and facilitate precision learning, precision medical care. If we combine this with what's happening now in terms of our ability to measure more about the biosignals related to our body and to our behavior, and then using AI for the analytics, the convergence of these three emerging technologies is going to make a really big difference in how we conduct healthcare. And it's worth, as you design new curriculum, new ways of moving forward with both education and clinical care, to pay attention to what this convergence means and how it will change the landscape of healthcare in the near future. Again, my affiliations, I have the honor of working with a number of different academic groups at my university, but what really propels me right now is working outside of the university to address some of our significant healthcare challenges. And one of the ones I'm personally very concerned about, and I think we all should be, is the issue of an aging population, not just in the US, but worldwide. If we look at the demographics and small family sizes, we're going to live so much longer than previous generations, yet we still have some very difficult problems that we have to address. Right now, by the time we get up into the year 2025, which is going to happen sooner than we think, 1 in 6 people in the world will be over the age of 65. 3 out of 10 seniors will be 80 plus and will be living with dementia unless we can do something about it now. So we have some time, but we have to start moving now to address the issue, especially involving brain health and aging. There's other problems too that we need to worry about with an aging population, not just neurodegenerative disease, but physical disabilities, pain, stroke, and then, more problems we've been finding at any stages of life, like cancer and heart disease. The pressure on our healthcare system is going to be significant with the challenges of an aging population, smaller family sizes, less caregivers to support them. Also, the type of healthcare problems that we're seeing with today's culture is shifting what we do and how we need to do it. Higher percentage, especially post-pandemic in our youth, with anxiety and depression. A lot of jobs now, there's a tremendous amount of burnout which we need to address. Problems with addictions. I'd say obesity we're getting on top of a little bit, but there's still significant challenges. So, of course, you all know, some of the ways to address this is to shift the point of care and the time of care in a different direction, to do more preventive medicine, more interventions there. And nicely enough, the technology that I'll be talking about helps us do that. We also need to shift the center of gravity of where healthcare happens, so that it's no longer at the clinic, no longer at the hospital, so it's where the patient is located, and facilitate better support in a more robust way where the patient is located, with avoiding the cost of moving into a more expensive facility. So the good news is, and I love this quote from Wayne Gibson, that the future is already here, it's just unevenly distributed. There are significant advances in answers to the problems that we're going to be facing with an aging population, with other healthcare issues. We just need to find a better way of taking what we already have worked on, what's on the way, and moving it out in a way that we can scale it faster. There's a lot of inertia in healthcare, and that's often appropriate. We don't want to arbitrarily change things, but where there's trade-offs between addressing some acute needs, both here and also worldwide, where we have to make some hard decisions of how fast to move. And that's, I think, one of the biggest challenges that many of the people in this room will face is, I don't like the expression move fast and break things, but I do think we need to move fast, we need to move aggressively, and we have to be careful at the same time. So helping our administrators, our regulators, the people that are helping us evolve some of the ethical issues work with us to move forward fast. I think it's going to be a key issue as we bring in new technology. So to get to the context and why I'm particularly excited about where we are now, we are in the middle of a digital healthcare revolution. You all know that. With instead of the center of gravity being the clinic, we're moving to where the patient is located. The patient is the center of care. We're also, I think, towards the tail end of a major shift of moving from an analog world of medicine to a digital world. I still remember going into a hospital and seeing stacks of patient records, physical records, that if they might be lost in someone's desk for months before you could find them, and just tremendous trauma. So despite the agony of sometimes incorporating EMRs, we're now moving into a much more robust digital system with all the data that we can collect and ways we can analyze it. The technology we're used to do our measurements now is digital as opposed to analog. So there's a lot we can do to harvest that data and improve our curriculum, improve what we're doing. We're also, because we can use smartphones, smart glasses will be here soon, as a healthcare data collection and a healthcare administration platform, we can now reach worldwide. Currently, there's more than half of the world's population has access to a smartphone. I think that will change as we move out with smart glasses and they move into more of the enterprise applications. So I think we should assume that we have a way to, in a digital manner, collect information and provide therapeutic applications worldwide. The data that comes in will be tremendous in terms of helping us evolve more appropriate care, more precision care, more better match care to an individual, especially with AI analytics to help us do that. Right now, we have some very sophisticated digital health platforms that have patient-facing applications, dashboards for clinicians, but also government officials, research scientists, everyone who has access to this very powerful data that's just terabytes occurring every moment, coming into on individuals and on healthcare systems. We can do a lot with that data and use it to come up with more breakthroughs and more precision applications. We have to find the right way to apply that data, though, that now that it's coming through, it's like a fire hose of data, and it's going to be very helpful, but how do we move it into the existing infrastructure? Of course, we all know what a big difference AI has done in terms of helping us master that pace of data that's coming in. But we also have to look at the challenges of having AI agents as our interface to that data and to each other and to the built environment. As you know, we're already in the middle of the era of medical wearables. How many people now are wearing some sort of medical sensor? I'd say 36% of the room. But if I ask you how many of you have a smartphone, I bet it would be 100%. And in my opinion, that is a medical sensor too. We get a lot of data from that is relevant to our behavior, to our activity levels, et cetera. So I think we are having a potential of harvesting, again, with people opting in to share that data for clinical purposes. I know that Google has at least 10 or 15 years worth of my email messages, and Apple has maybe 10 years worth of text messages on their servers that I've done. That data can be used as an indication of my brain health, for example, also my social activities, et cetera. So there's a lot of passive data we can get from unobtrusive sensors. Again, we have to figure out how to harvest that and make use of it in a way that protects patient confidentiality. I'm very excited about the advances in affective computing, the field of using data that we can collect to measure the emotional and the cognitive state of ourselves and each other. We've had trouble in the field of psychiatry and psychology and coaching, understanding objectively someone's emotional state. We can ask someone how they're feeling, and it's hard sometimes for us to describe that, recall that from how we felt last week with the new medication. And it's also hard to be honest with ourselves and with each other about that. So we're now finally able to evoke a cognitive state using virtual environments, simulations, and then using biosensing measure emotional states. So the field of affective computing is really going to make a big difference in the field of mental health, psychiatry, psychology, coaching, behavioral health in general. I'll give some examples. Right now, for example, we can get passive data from our smartphone. Again, if people opt in to share that data. Voice analytics are being used as a objective measurement of anxiety, of depression, and of pain, other states. And then we're capturing facial expressions and eye movement data also to index cognitive and emotional state. The combination of these signals allows us to be even more precise. So there's some large data sets that are out there already that can be accessed that can do some amazing things. One of the groups I've been talking to recently has a large data set of eye gaze data where they can take data from a cell phone or from a webcam and measure reading comprehension of the individual. To me, that's a tremendous thing, to start getting objective measurements of someone's cognitive state or their emotional state. And again, now with the ability to use simulations to evoke or challenge people in different ways, we can come up with much more objective ways of moving forward. There's also breakthroughs in ways of measuring cognitive function. I'm excited by what's going on with some of the mobile FNIRS technology, where we can measure the function of the forebrain very objectively and less expensively. Starting to get beyond glucose, the things that we can collect, hormones and other biosignals that we can get non-invasively. And then, of course, our sensors are part of everything that we're seeing out there. So many cameras, so many things built into our cars, our refrigerators, our everything we use is going to be very sensor laden. And again, with the right sort of design and ethical considerations, we can leverage that data to improve healthcare. And I know there's a big thrust here to leverage how we can do so much with digital twin technology, build models of ourselves or the environment or our communities, and be able to use that to help evolve better healthcare systems. To me, that it's particularly exciting because now we can finally integrate the electronic medical record and have something that's much more functional. But I should point out that digital twins are not just about collecting data about the individual. We can also collect data about so much about their families, about their communities, about the towns they're living in, and combine that with other information that we can get. So there's a huge amount of data, and we only see really the tip of the iceberg with some of the things that we're able to collect right now. But so much information can be put together. And again, finally, with some of the AI analytics that we have, we can make sense of this data, come up with ways to do more predictive modeling of what's best for the individual in terms of their healthcare patterns. So the era of precision medicine is approaching, as you know. And we also need to be aware of some of the challenges are going on in terms of changing in the business environment, some of the business trends. The tech titans are moving into healthcare. We've seen many examples of that, and I'm particularly excited by some of the things that are leveraging wearable sensor technology, but also how we can look at big data and move it forward. So we're going to see it's not just going to be medical device companies, it's not just going to be pharma, it's not just going to be large healthcare networks. It's also going to be Apple, Google, Samsung, Meta, all being part of the healthcare ecosystem and helping us again design for the future. So we need to have a dialogue to help them do it right. If we can give the requirements documents to these groups, both the tech titans and the small earlier stage companies that are moving into this arena of what we want, they will build it if we show them a pathway to market. So I think it's important to get beyond the academic arena and start more interacting with the landscape of some of the technology companies that are out there. We need to get our regulators up to speed too. They often can be part of the inertia of trying to improve healthcare, but they're willing to evolve, and they will evolve. We now have some better systems at the FDA for looking for software as a medical device or new ways of looking at breakthrough digital applications. But they need a dialogue with us in order to help us move things forward, especially with some of the new objective measurements we have. And then, of course, telemedicine, we need to leverage that. And then, again, I think we need to focus on mental health because it's been a underdeveloped area in terms of having objective measurements that we can use for a more precision approach. The pharma companies are getting excited finally about the idea of combination therapy. They can sometimes extend the patent life of a medication by reformulating it as combination with a digital therapeutic. There's a little bit of resistance on the part of the big pharma companies when it comes to a precision approach, because if we can identify that 5% of the population is unresponsive or maybe negatively responsive to a particular medication, they lose market share. So there's been an initial hesitation on their part to jump in, but there's been some groups that have gone beyond that hesitation, saying, yes, we may, with precision analytics, we may lose some market share from some of our established drugs, but we can come up with new medications and match them better to the patient's needs. So I think one thing to keep in mind is what the tech titans will be doing. The future for them is to personalize the agents that we're going to be interacting with. If we can assume that in 3 years, 5 years, 10 years, whatever time frame it takes, that we will have one interface, perhaps not something we look at it on a screen, but we talk to with our smart glasses and have an avatar show up. If that's our interface that we're going to have with the built environment, with our automobiles, with each other, then that interface is going to be studying us to be more effective. It will want to know our predilections, our mood. Did we get enough sleep the night before? Do we have a cognitive impairment? There'll be an adaptation of these avatars as they get to understand us and know us with all the sensory data that they can collect from us just by looking at a webcam or using a smartphone to make decisions. So assuming that there will be a platform for us to be able to collect relevant psychophysiological and biological and behavioral data from the platforms that we have, and that those systems will be designed to understand us, we need to leverage that as we build the next generation of medical technology. I think the precision analytics that can come out of this and the personalization, building upon technology that understands us, interprets us, and adapts to us, we have to get ahead of the game on that, because otherwise it will be something that will be foisted on us without us having input on the design parameters. So it's on its way. It's being designed right now by the tech titans, and we need to have a dialogue with them to make sure they build it so that we can use it and use it ethically. But again, there's a lot of amazing things going on. There's groups with large data sets of eye gaze data that now with AI, we can use cell phone data to see if someone's at risk for Parkinson's, for example. We can, again, look at what's going on in our cell phones, the internal sensors they have, but also how fast we type, what we text when we type, who we're interacting with, gives a lot of behavioral data and cognitive and emotional state data. And then, other things such as voice biomarkers of anxiety and depression. The combination of these signals will be even more powerful than any of these by themselves. So we will be getting into an era where we have new tools to measure. And this applies as you're looking at medical education. We can also take a precision approach to learning and education. We can understand the individual's learning style, the individual's pace for learning, and individual skills, and adapt the training environment, the learning environment to match that. Of course, this is going to give new powers to the clinicians as they have all this data about an individual and more precise protocols. We have to design to not overburden clinicians too. They have enough going on. And so we need to make sure that we design for reducing the time burden, reducing the cost burden of bringing new technology into our healthcare ecosystem. And I think a great place to do that is at a facility, a place like here where we're rethinking the ways we train medical students. We can also design the interface to information of the future that will be used in medicine, leveraging what we're learning from our training paradigms here. So I want to get back to my focus area, which is immersive technology and how it can be used clinically. It was an exciting time for me. I got involved in the field back in 1987, if you can believe it. And it's been wonderful to see how we finally are crossing over. XR, VR, AR is not just viewed as this exotic thing, science fiction thing. We're starting to see it used clinically, and the cost has come down. The validation is there. Things are moving forward. So again, I got involved back in the early days when we had computers the size of a refrigerator that cost $500,000 and pretty uncomfortable headsets. I'm sure my high forehead is due to wearing so many headsets over the years. But it's been a wild ride, and I'm really excited to be here with you today to talk about where the future lies for this technology. I've had a number of wonderful colleagues who have contributed to this. What many people don't appreciate is that we already have a large amount of data on how to use clinical XR experiences. The challenge is that these are done with technology that is evolving every 2 years. So if you do a study that takes a year and a half to do with a small data set, and then you go to publish it and go through the review process, you might be talking about technology that's 5 generations old. So as you design your training systems and your research programs, I would keep that in mind, is that the technology is rapidly evolving that we're using to collect our data, and just make sure that we have a foundation of the particular type of measurements and have that be the key factor rather than necessarily the particular technology that we're using, because it's changing pretty fast. What I'm seeing in terms of new technologies in simulation in healthcare, we're finally getting to multi-user worlds. Most of the VR experiences now are pretty lonely. It's you and a 360 video or maybe a computer-generated video. And if there's another person there, they look like a robot. But now with cloud-based rendering and pixel streaming, we can have much more robust environments. And we're finally getting our avatars to have some non-rude behavior to them, where they actually have body language, facial expressions. If there's a group of avatars standing and talking and your avatar walks up to them, they're not going to be rude to you. They'll do what we automatically do, which is maybe welcome someone to a group discussion as opposed to staying like this. So the virtual world technology is evolving. I think I would keep that in mind as you design your systems. It won't just be a solitary experience, or it won't just be an experience where the other people in the environment are robots. We're also getting on the other side of the uncanny valley, where the technology we're using isn't going to look creepy if we have avatars of ourselves or others. Finally. And we're also getting new ways to put information in, like haptic suits, tactile gloves that give haptic feedback. So that's an area where we need to make more advances. Some of the new things I'm seeing is where if you pick up an object in a virtual world where there might be a vibration or a buzz or a sound that corresponds to the heft and weight of that object, so our brains learn to adapt to that, and we feel like we are picking up something that has some weight to it when we have those additional sensory stimulation. So right now, in terms of clinical VR, there are many, almost every clinical area has some new technology supporting it using VR, AR, and XR technology, and there's almost 500 emerging companies. Now, what hasn't happened is the large medical device and pharmaceutical companies coming in a big way. They're still sort of standing watching to see what these early stage companies will do. Part of the problem has been reimbursement. It's hard to bring new technology out if there's not a business model behind it. But one group that's been leading the way is the Veterans Health Administration. They have brought VR out to address more than 30 different clinical indications. They've trained thousands of clinicians, and they've had thousands of veterans using VR systems clinically. They're starting to have some telerehabilitation and home programs using VR, being sent home with the patient too. One of the reasons they've been able to move forward a little bit faster than some other healthcare groups is that they don't care about the CPT codes. If something is effective and reduces, if it works and helps the healthcare ecosystem, they'll embrace it. So that's been sort of the workaround to the inertia we've had with reimbursement. So again, every VA has something going on right now worldwide, and we're starting to see some reimbursement pathway. The CMS just came up with one code for durable medical equipment that has VR. So there are some pathways for reimbursement that are starting. So to give some examples of where we see things going now, really the full stack of healthcare is being impacted with training, assessments, interventions, ways to facilitate adherence, ways to reach underserved populations, and ways to facilitate prevention and wellness. I only have time to give a few examples, but I'll do my best. When it comes to clinical training, and I know that's an area of special interest here, again, it's really been this full stack of training that's part of a educational process in medicine, ranging from interpersonal skills, specific equipment and tools, how to do team training, how to help facilitate empathy by changing the perspective, being in the shoes of the patient, or being in the shoes of your colleague who is helping you do a process. And being able to see the spinal tracts in 3D to me would have been wonderful as I was learning neuroscience. So we now have some new ways to visualize and again, personalize the skill learning to the individual's learning style. Some of us aren't very good at visualizing things and remember things visually. Some of us aren't very good at looking at text and comprehending dynamically. Some of us need to have experiential learning. We now can do a more precision learning approach and match the learning style of the individual to the pace of the information, the type of information we provide to them. And again, with generative AI, we're getting a huge library of simulation environments related to different procedures and different approaches. And I know there's some very exciting work here going on, for example, with collaboration with Mayo, with radiological technician training. Just one example of how we can facilitate education by showing what otherwise can't be seen, by speeding up things, by creating worst case situations where there's an emergency that you hopefully will never have to deal with, but you need to be prepared for. We can simulate that much like we do using flight simulators. We can do that for clinical training. We can also, of course, come up with simulations of the patient experience, allowing us to practice our communication skills and practice and learn over and over till we get it right at our pace. And one important part of that is that we can learn how to be ready for difficult situations. You don't want to learn on the job how to give bad news to a family about a terminal illness. It's better to have a chance to practice that separately. Now, of course, we can do that with role-playing and in groups, but the variety of responses, the variety of challenges in ethnic groups are hard to do with one-on-one training, but we can do that with simulations and be sure that we can provide the right sort of empathy as we deliver that sort of bad news. And again, one of the things I'm really excited about is how the technology is allowing us to do much more objective measurements than ever before, both in the field of mental health, but also physical therapy, occupational therapy, all aspects of measuring patient response now is going to benefit by better sensors, better analytics, and better ways to evoke a congruous state or a emotional state. We're already seeing new ways of doing measuring and promoting physical therapy and occupational therapy. Because we can capture movement very precisely in a functional way in a simulation, it's much easier than just getting a goniometer out and measuring in range of motion. We can measure function. And then we can use a variety of ways of creating different situations in for cognitive assessment. It doesn't have to be where we're wearing something on our head. We can step into a room and we have someone go on a quest or on a task, do a challenge, see how they react, measure their voice tone, their eye gaze, their heart rate, and their EEG signals. There's ways to obtrusively or unobtrusively collect data that allows us to come up with much more functional assessments. And all aspects of executive function have been moved to ways we can collect them. There's one way of using a VR headset not to create an experience for an individual, but to use the eyes as a rapid way of making choices, going down different assessment pathways, doing like an NBAC test, for example. But because the eyes move very fast and react very quickly, we can do a much more precise functional assessment of all aspects of executive function. There's some groups that are trying to put all this together into one comprehensive way where we bring an individual in, we measure their physical strength, their range of motion, their endurance. Hand in hand with that, we're capturing all aspects of brain and cognitive function simultaneously to come up with an individual measurement of everything in response to a challenge. I tried out one of their environments I was very jet lagged at the time, but they put me in a simulation of a air traffic controller situation where I had to remember the call numbers of the planes that were landing and how much fuel they had and who was on what runway. I did not do very well on that task. The next one I did much better. They put me I was in a simulation where I was on a first floor landing, looking down an alley, and I had someone down there was throwing me cans of spray paint. And my task was to listen to the sound of the spray paint as it came up, because then I would know what color it was. And then I had some graffiti that I had to do. It was actually pretty fun. But through that, they got like my soaker. I think I must be triggering the lights here with my motion. But I got to do a fun task that I wanted to keep doing it again, but it evaluated my motion, my ability to sequence, my ability to pay attention, so many executive functions just in this one very brief, fun task to do. So there's new ways we can do these assessments that aren't as arduous or as analog or as lame as some of the ways we've been doing it in the past. No offense to our amazing colleagues who have been in the field working so hard using assessments that are based on question and answers. But I think now we have a new era of measurements that we can bring forward in the field of mental health, behavioral health. And again, it doesn't have to just be evaluating these systems independently. There's one company that uses a AR tablet to do a memory test in a room where was this object, where was that object. But they capture the movement along with the memory task and come up with a fingerprint for the individual. They have FDA breakthrough device development to come up with a precision test related to Alzheimer's disease. Just one example out of many of how new technology is being used to come up with new assessments. And again, something to keep in mind as you come up with new training paradigms. I'm excited by some of the things that are going on in the field of pharmacology, where they're now starting to use assessments to identify the responders for a particular medication and go back to some of the medications that didn't quite make it to market because they weren't able to have a medication that reached enough of a population. They can now go back and say, wait a second, we can identify those people in particular that respond to this medication through a variety of different ways. It is now worth bringing that investment that the pharma companies made in these medications that they didn't bring to market, because now we can show them a pathway to bring it to market by matching it to the right individual response. Again, the era of precision medicine. Another example is my colleague at Stanford, Lee Williams, who runs the Stanford Center for Precision Mental Health and Wellness. What Lee does is identify different subtypes of depression, and she uses this by a variety of ways. She looks at genetics, proteomics, metabolism, but more particular imaging. She uses an fMRI machine to identify different neural circuits for the individual, challenge them, and we use VR as part of that challenge, and identify their particular neurocircuitry that is related to their subtype of depression and match that to the right medication. Much more precise way, and I think that will be how we do things in the future, is coming up with better ways to evaluate the individual's particular response, leveraging biosensing, leveraging new imaging technologies, but also new ways of evoking and measuring cognitive and functional states. I think this will change us from the one-size-fits-all approach that we've had from many aspects. And psychiatry is one example. Really, all aspects of medicine, we can do more of subtyping by leveraging the sensor data we're able to get. So some of the challenges that we have, if the students here are looking for projects, we now need a library of age-appropriate, culturally diverse environments that can be used to evoke different cognitive states of sadness, of joy, of frustration. We need a larger library of content that can be used as part of this next generation of healthcare, so that we can use it to test and evaluate. So as part of what you'll be designing for part of education, I think that same content can be migrated out to the clinical world for better assessments and interventions. Again, we're learning from our fields in the gaming industry and the entertainment industry how to make something difficult and ineffable as such as motivating someone to adhere to a cognitive rehabilitation process by making it a game. So there's new ways now that we have evocative environments that we can dynamically change based on a biosignal, that we can create better ways of doing physical therapy, occupational therapy, neurocognitive therapies. So those are the field of assessments, really interventions. We've seen some fantastic work of pre-surgical planning using image data. So a surgeon can sit with a patient and say, I have some choices on what I'm going to do for your neurosurgery. Let's talk about the trade-offs and show them in a way that's much better than walking on a whiteboard what the challenges and trade-offs are. And also the surgeon can work with collaborators to design the most effective approach. Again, new ways of promoting physical therapy and occupational therapy by providing feedback of progress, showing people how we can make a difference there. And then in mental health care, again, we're all aware of how backed up our system is and how there's such acute needs in today's world and not enough clinicians to help support the urgent needs. But we've been able to use virtual environments and biosensing and AI to address almost all aspects of mental health care. To give a few examples, we use, if we're trying to help someone who has had trauma and has being triggered by certain aspects of that, we can gradually do exposure therapy, but the brain doesn't want to go there if we're just asking the individual to think about their trauma. But we can gradually expose them and take them there in a way that doesn't re-traumatize them by using simulated environments. Same paradigm for phobias and some other anxiety disorders, is we can evoke and gradually have people work on things. And a similar paradigm applies for addressing addictions. We can create a simulated bar scene where a patient can practice resisting peer pressure and remember what to say to friends who are putting peer pressure. We can also reduce the habituate their response to a particular stimulus that might be inducing a craving, and so to build situational confidence. And then we're also seeing a lot going on. I've been talking mostly about the clinical and educational aspects, but we're seeing a lot crossover into the wellness arena, where we use VR systems to help people learn relaxation skills, focus skills, and these tend to be very transmedia applications where they're not just on a VR headset, but same paradigms get moved to remind them they can be on a cell phone or a watch. One thing I've been excited to see is that one of the big difference between mobile-based mental health applications and what we've been able to do with immersive technologies is better adherence. I think because we can create a more engaging cognitive experience, more engaging emotional experience, we don't see the high drop. In many of the mental health apps, people use them for 2 or 3 weeks and then they stop. But we don't see that with the mental health apps that we've been doing using immersive systems. Another example, very rapid adoption, really across the world in using VR as a way of distraction from uncomfortable procedures or helping addressing chronic pain. And then again, we have amazing systems in the health and wellness zone to promote exercise and weight management, stress management, ways to address it as a disability interface, and ways to connect people and reduce isolation. I'll just give one example of a wellness application where a group has a system to help people practice making the right food choices and see the consequences of those choices. So you can have your avatar lose weight and look much more buff and wonderful, or look worse depending on your food choices. And there's groups that are doing that dynamically using smart glasses technology, where you might look at what you're making, what you're going to buy in the grocery store, or what you're going to sit down and eat, and get some feedback on how it's going to, instead of waiting months to see the impact, see it right away. So it's happening. So now I'm going to try and, if I have time, I think I do. No, we're almost there? Okay. I'll briefly say what is the mechanism of action? Why are these simulations and virtual environments combined with sensing and AI making such a difference. And it's because we can create the context in a much more robust way. We can activate the reward systems of the brain and gather someone's attention, and that shortens the feedback loop and promotes insight and perspective, and we have emotional impact. And that's what we remember, is experiences that have emotional impact. And again, we can do much more objective measurements. We can also leverage mirror neurons. We can create an avatar of our future self, and we can have a dialogue of our future self. We can have what we're learning or what we're doing be reflected in the health status of our future self. And our future self can give us a phone call if we opt in to let them do that. If we're trying to reduce our amount of alcohol, it can call us up when we walk into a bar and say, "What are you doing here? Look what you're doing." So feedback is really important, and perspective taking is really important. Also, with simulations now, we can put narrative stories, and that's how we learn, is by having storytelling as part of it. So a big part of any educational curriculum is building in narrative stories as part of it. That's what causes us to remember, recall, and stay involved. So I think I'll pause now for some questions, and happy to talk afterwards. I was going to talk about ethical considerations. What else? All right, one more thing. I have to mention this. All right, what are the constraints? Well, we need research. Much of what I've been talking about has been done on small group studies. We need to move it forward with better controlled studies with larger sample sizes. We still have the perception of digital technology and XR as a science fiction thing, so we need to help get over that. And this is where many of the early stage companies make a mistake, is we're not designing as well as we should for a busy clinic, for a overburdened healthcare system. We need to realize that the products that we're pioneering and bringing out need to fit in not just by having better results, but by reducing time burden, reducing the cost burden. And we have to deal with the interoperability issue. I want to mention one of the books I'm really excited about by Nita Farhani, The Battle for Your Brain. Many of the things that I've been talking about we're at risk of, if we're not careful about protecting the data, providing it the right way. I think our new ways of evoking the ways our avatars will be interacting with us also puts us at risk of having very precious, very personal data about our motivations, our choices, our personality, our predilections. We'll want to have that in healthcare system. We don't want to have it be used by people who want to sell us things or influence us. And we also have to keep in mind that just because we can come up with a risk factor for someone, they're at risk for suicide, that doesn't mean they're going to do it. And we sometimes take the data that we collect and say, here's a probability of someone. We need to realize that there's still a lot of individual choices that need to go on, and how best to handle as we get more precise at that issue, revealing that. So anyhow, I'll just summarize real quickly. I'm excited about what's on its way, what's happening right now. I'm excited about what's being done here, but I'm also concerned we have some hard problems we need to address. So I'm happy to help in any way I can. I'm very excited to meet and understand all the momentum and possibilities that are here. Thank you very much.
Excellent talk, and thank you so much, Dr. Greenleaf. We'll take questions from the audience. I'll be walking around. Don't keep in the chat yet.
Thank you, Dr. Greenleaf. This is a fascinating summary of the work. My question to you is, as these technologies are being developed, they seem to be more geared towards a certain segment of the population, and we run the risk of introducing even more disparities in who benefits from these tools versus a huge swath of population who may not benefit at all. How do we close that gap?
You're absolutely right. In the past, a lot of our clinical trials have been very biased by the populations that we had access to. And also, I think it's really a design criteria that we need to factor in. It's designed for diversity, designed for different application areas. I think one of the things that we can do is leverage more telemedicine applications and can use generative AI to dynamically change the content of the applications we have. I think it's a choice, and I think we just need to make the choice that we're going to design for diversity, design for different age group, different cultural groups, and be sensitive to that. I think now we can. I think in the past it was difficult to do so, and we didn't have it built in as part of our requirements. But now I think we can.
So thanks for a great talk. So these things are, the Apple, the only one I'm familiar with really is the Apple VR or extended, whatever it is. And they're really expensive. And what do you think about, can you say something about maybe insurance coverage for these things as they become reality? And even if you get something FDA approved, does it mean the insurance is going to cover it?
It is a big issue. The cost of the technology is coming down. Google and Samsung just announced a new VR headset that is very similar to the Apple Vision Pro, but about half the cost. But I think it's the smart glasses technology, which will have a spectrum of immersion and the ability to capture key data such as eye gaze data, other physiological parameters. They'll be used in the enterprise. They will replace our smartphone. People won't have a phone in their pocket as much as they'll have some glasses they're wearing. And I don't like wearing glasses, but I think it's our future. And that interface will be part of the enterprise, how we work, how we socialize. And that will be, I think, our platform for healthcare. So I think as you design your training and your clinical applications, I would anticipate and maybe have a dialogue with the groups that are rolling out the smart glasses technology and help them design it for healthcare. I think the costs will come down. In the meantime, we have to work with what we have. But believe me, the headsets I worked with in the past were $100,000. So they do come down. Now for half the cost of a smartphone, you can get a really great VR system. And we have to show the value of it to the FDA and to the reimbursement groups too.
So yeah, once again, great talk. So I want to return to this concept of FDA clearance and regulation. Because most of these technologies rely on AA models, which are effectively black boxes. And as we know, every year they need to get updated. The model itself changes. And of course, whenever we do anything to a person or diagnose a person, we need to know how accurate all that's going to be and how well it's going to behave. So where's the FDA in all this? How are they going to handle updates and changes to the model and how it's trained and all that stuff?
They're trying very hard, and they do have some people that are specifically focused on this type of technology, trying to come up with their evaluations. There's a certain amount of inertia there, and I think we need to help them figure it out. I mean, that would be one of the things I think would be a value of any group that's moving into simulations is help the FDA understand how best to regulate, because they want to do it right. I would also say we need to use more of the metaphor instead of AI viewed as a robot. We need to view it as like Tony Stark's Iron Man suit, where we're inside of it and we're controlling it. It's providing information to us, and it may be black box information, but we're inside of it and we have exposure. We can look at details anytime we want. So part of it is how we design agency and visibility of the algorithms and the decisions. But you're absolutely right. It's something that is a challenge because of the black box nature of AI, but we can get our arms around it.
Hi, thanks so much for your talk. My name is Leela. I'm a student at ASU's new public health technology program, and we talk a lot about the importance of human-centered design. So I was just wondering, you talked about like co-creating with some of the companies, but I was wondering if you have any examples of co-creating with the actual users or the people who are going to be like affected by these technologies, because there's a lot of concerns like digital literacy and like mental health is a very sensitive subject. So just wondering if you have any concrete examples of that. Thank you so much.
There are some concrete examples, and I wish there were more, because I think you're absolutely right. And that also addresses the question earlier about how do we make sure we don't build in biases to what we're doing. I think it starts at the design stage. Good design, and often early stage companies don't put the time and effort they need to do good upfront design. We need to design for diversity. We need to design for different age groups. We need to design for different cultures. And we need to bring in the ethnographers in advance to help us design the right way. So to me, it's big D. And we can't really do good programs of any sort, training or clinical care or wellness products, unless we put the effort to think about designing for those key features, but also downstream effects. I think often companies don't think about the effect on society of what they're building out. And we need to just show by example the best way to do that. So I can later afterwards, maybe I can give you some examples of companies that are doing good design work. Unfortunately, they're few and far between. But there's no reason we can't now, especially with generative AI. We can dynamically change the simulation, the experience to match the individual.
Yeah, thanks a lot, Dr. Greenleaf. So I want to shift a little bit into the area of medical education. And as we develop a very innovative curriculum, we're still up against a accreditation process that is pretty much back around 100 years ago with Blackstone. So how do we go forward and prepare our students for this world that you are describing and use new educational approaches with an accreditation system that is probably 10, 20, 30 years behind that? Any thoughts about that?
A couple thoughts. One is think globally. A lot of what you're doing here is going to have global impact. And I think there are some places that have such acute needs that the certification, they're not going to wait for some of the regulatory issues. They need your help now, and as soon as you can do it in terms of training, education, and clinical care. I would also say give the requirements documents to these agencies. They're coming in trying to evaluate you, but they're learning about new things as they go. And they probably have people who are stuck in the past on their boards. I'm just assuming that. And I think a lot that could move things forward is have a program where you help educate what's on the way and get their engagement. As you design new educational systems, they should be part of that process so they understand what you believe can happen and when you're ready to bring it out, they can say, we understand and we approve. I think it's incumbent upon them really to listen to you and help evolve the evaluations that they do. It's easy for me to say that, though, but hopefully there could be more of a dialogue.
Great, thank you. Any questions in the room? I'm going to check the screen up.
Hi, thank you so much for your talk. I have a question about the mechanism you brought up for how this works seems like universal, but I wonder if like the AR and XR technology, does it have like universal applicability in the sense that like does everyone improve by engaging with that as opposed to current technology? Or are there certain like subpopulations that benefit better, like people who aren't able to visualize things as well or something like that? And if there's been research on that, and I guess what the implications of that might be for FDA approval or like insurance enumeration and stuff like that.
I'm so glad you asked that question because I'm probably out of the sake for being comprehensive, didn't go deep enough on that particular issue. I do think that we all have different learning styles. And if we're building an educational system, it may be that some of the simulations or the designs that we have might not work the best for everyone. So what we really need to do is come up with better ways of evaluating an individual's preferences and styles, what works for them, and then make sure we design a broad spectrum curriculum that doesn't exclude anyone, doesn't make someone fail just because we're not designing for their learning style. So it's easy to say, oh, everybody is a visual learner, let's just have a lot of visuals in. But I think we need to make sure that we fingerprint individuals, and just like we're trying to come up with more precise clinical care, come up with more precision learning approaches too. And you're absolutely right. It may be that some of these new things aren't as good for some people as the older things. So we should have it's easy to say this, but I think we need to have a spectrum of ways of addressing learners' needs, leveraging the past, but also building for the future.
And one last question. Thank you for a wonderful talk. My question relates a little bit to the one that you just responded to, and that is adapting these technologies for people with sensory impairments, auditory, visual, or other impairments or different abilities. When I first learned about affective sensing from facial expression, it was in the context of an assistive technology for individuals with autism who have difficulty processing emotions, and that's a whole different application of using these as assistive technologies rather than just assessing or treating technologies.
Right. I think again, it's just a matter of if we had more time and more resources, we could be more comprehensive in this. But in the example of people on the autism spectrum, what we've been able to do is build systems that understand their ability to sense emotional states in others and then exaggerate. So we can get to the point where exaggerating a facial expression or changing a voice tone and helping them recognize that in others, reinforcing that, and then reinforce their learning as they go along. So I think that the key is to understand someone's strengths, someone's skills, and also someone's deficits, and try and design to be comprehensive. So I do know in the field of helping with autism spectrum disorder, there's been some groups that have done some really effective ways of providing therapeutic and learning environments that address the specific individual's ability to sense emotional states in others. But that's something that isn't often designed for. As we build systems for the general public, especially the tech companies, they're more interested in numbers and they're not necessarily interested in being comprehensive. So I think we have an opportunity to sort of, as we design new systems here, show the pathway of how to be comprehensive, addressing, how do we design for someone who doesn't have, good visual acuity or good auditory acuity or may have a cognitive impairment of some sort. That's the challenge. And I think we have the tools to address it. So to me, again, it goes back to the issue of design. We need to design for addressing those needs too.
Great, thank you.
And again, it's easy for me to say that, but that's, I think, the way we have to go.
Great, wonderful, thank you. Let's give Dr. Greenleaf a round of applause. Wonderful. I'm gonna pop up the evaluation for those that need it at the end. We will send this out electronically too, just in case. And thank you so much for all being here, and thank you those that are online.